Hey guys, I'm Matt, a developer from Ohio, and in this video, I'll be walking you through the Wanderlust project. To complete this project, you'll need to be familiar with GET requests, asynchronous functions, queries, and JSON objects. Let's get started. In this project, we'll make asynchronous GET requests from the Foursquare API and API-XU. If you haven't already, you'll need to make accounts for both of these APIs. Follow the links in the project introduction and save your Foursquare client ID, Foursquare client secret, and API-XU key. Once you have those, we can begin. A lot of this program is filled in already. At the top, you'll find a section for Foursquare API information. Copy and paste your client ID to be the value of client ID. The ID I'm putting is unique to me, but yours should be pretty similar. Also need to copy and paste your client secret. The last piece of information we need from Foursquare is the URL we'll use. This URL is the endpoint that we'll send our requests to. We're accessing the Explore Venue part of Foursquare's API. This will return some local venues near the location that we send it. The URL can be found in the documentation link provided in this task's instruction, and that's this. We're also going to add the near parameter with no value. We'll insert the value later based on what the user types into the search bar. Remember that a query begins with a question mark, so that'll be question mark, near, and equals. So the name of the query is near, and we're going to set that equal to some value later on. Now on to API-XU. Copy and paste your API key as the value of the constant API key. Again, the key I'm using is unique to me, so you'll need to get your own from the API-XU website. For forecast URL, we're going to add an endpoint, just like we did with Foursquare. This one will return weather data about the location we send it. The specific URL can be found in the documentation link provided in this task's instruction. We'll add the key parameter. Again, we'll leave out the value because that'll be added later on based on which location the user enters. So that'll be question mark to start a query, and then key equals. We're going to send a GET request to the Foursquare URL we defined above. This will go in the getVenues function. Before we start on the specifics, we need to add the async keyword. We use asynchronous functions for requests because they can take varying amounts of time. We have to wait for a response from the API. So before the parameters here, we'll add async. We need to know which location to send to Foursquare. This will be what the user types in the search bar. We'll save the value of input as city. So a new constant, city, is going to be input.val. So input here, up above, is saved to be this bar, and val is a function that gets the value of whatever you type in the bar. So for example, if I type in a city like New York, then input.val is going to be the string New York. Now we'll construct the full URL that we'll use to access information from Foursquare. Remember that we ended our URL with the near parameter in task 3. We'll append city after that to complete the query. So a new constant, URL to fetch. We're going to set that to a string, but we're going to use backticks here instead of quotation marks because we're using string interpolation, which looks like this. We're going to add in the URL variable, and we're also going to add in our new city variable. So this is pulling in the URL that we saved above. This ends in the near query, and we're setting that near equal to the input.val. So that's going to end up looking like near equals and then whatever city you type in. We'll need a few more parameters as well. If you're wondering how you'd know which parameters to use, it depends on the API. Normally you'd have to read over the documentation, but this task's instruction is providing that information for us. So next up is the limit parameter, which will indicate how many venues we want Foursquare to return. In this case, we're going to use 10. So to add on another query, we need an ampersand, and then that one is called limit, and we're going to set that equal to 10. Then we'll add the client ID. This tells Foursquare who is requesting information. We saved this as a variable in task 1, so we can pull that in. Ampersand, client ID equals, and then this is our client ID variable. We also need the client secret. You can think of this as the password for your client ID. So that is another ampersand, client secret equals, and then we pass in the client secret variable. Lastly, we have v. The number you put in here will be today's date. Again, this is just something that Foursquare's API asks for in a request. So that'll be ampersand v equals, and for me the date is 2018-07-24, but you should put in whatever the date is for you. We'll use a try-catch pair to handle any errors that might occur in the request. The request code will go inside the try block, and the catch block will only run if something goes wrong. That'll look like try, and then the second block is catch, and to that we pass an error. this case, we're just going to log the error message in the catch block, but you could also use the space to display an error pop-up in the web page, redirect the user to a 404 page, etc. So we're going to console.log error.message. So if something goes wrong, that's going to produce an error, and that error is going to have a message attached to it, and we're going to log that to the console. In the try block, we can make the request using the fetch function. By passing in the URL to fetch and no second parameter, we're making a GET request. We use the await keyword because we need to wait for the response to come back. So that'll be a new constant, response equals await fetch URL to fetch. So we're passing this URL into fetch, which formats a request, and we're awaiting the response from that, and then we save that response so that we can use it. When we get a response back from Foursquare, we need to make sure that the response was successful. All responses will come with an exit code. You probably heard of a 404 error. A successful status code will be in the 200 range. If we get one of these success codes, then response.ok will be true. We can use a conditional statement to make sure we got a usable response. So if response.ok, in this block we will use response. But if it's not okay, meaning that the request failed, then we're going to throw an error. We'll throw a new error, and here we're going to give our error message. In this case, it's something like request failed. And if this happens, so if the response isn't okay, we throw this error, and that's what's going to cause us to come down to this catch block. And our error message is request failed, so we'll console log error message. We'll log the response to the console to see exactly what it is. So console.log response. For this next part, you'll need to open up your developer console. I'm using Google Chrome, but it should be pretty similar no matter what browser you're using. In Chrome, you can right-click anywhere and select Inspect. That'll open up this panel, and you can move over to Console to get to the developer console. Now, to get this to run, we're going to have to type in a city name and hit Enter. So for example, I'll type in Columbus and hit Submit, and we'll get our response object back. Like we talked about in the last task, an OK status is in the 200 range. You should see that the status property of this response object is 200, and the OK property is true. So where's the data we asked Foursquare for? It's stored in the URL property. If we copy and paste this link into a new tab, we can take a look at that data. And this is what that data looks like. It's a little hard to read, so I'm going to open it in a different tool to make it a little more readable for us. So the data we got back from Foursquare represents 10 values that are near the location we typed in. We're looking for items, which is an array of venues. Your specific JSON might vary a little bit, but on mine, it's around line 58. So here, on line 58, I have items. And inside of items, we have these individual venues. So here you can see a venue. It has an ID number, it has a name, it has an address, all sorts of information. And we're going to be using each of these locations to display. So when the user searches, in this example, I searched Columbus, they're going to get things back that are near. In this example, we got Ohio Theater back. Back in our program, we need to get that items array out of the response. First, we'll use the JSON function to extract the whole JSON data. We'll need to use await because JSON is an asynchronous function. So a new constant, JSON response, is going to equal await response.json. And this is basically going to get us that object that we just looked at. Now, if we looked into the console, we should see something pretty similar to what we looked at in the previous task. So we can console.log the JSON response. This thing we get in the console that starts with meta is the JSON object. We can click on the arrow next to it to expand it. We're going to go down a few levels to find that items array. So under response, and then under groups, and then under 0, we can see that items array, which is full of different venues. So items is located at JSON response, that's the whole object, and then response, groups, 0, items. We'll save that to venues because this is the part of the data that we care about. So a new constant, venues, is going to equal JSON response, which is our whole object, dot response, dot groups, 0, dot items. Again, this is just kind of going down the list. So we start with the whole object, then into response, then into groups, 0, and then items. Let's log venues to the console to see what we're working with now. So console.log venues. Each array item here, 0 through 9, represents a value, but still has some information that isn't useful to us. What we need is the venue property of each item. So we can use the map function to grab the venue from each item. On the end of this JSON response groups 0 items, we can add the map function, which is going to take a parameter, in this case the item or the venue, and we're going to then use an arrow function to return item.venue. So for each of these, for example, for 0, we're going to return 0.venue. And then we'll do the same for each one. We'll turn 1.venue. We're getting rid of all this other stuff, like reasons, referral ID, etc. Remember that we're working on the getVenues function. Now that we have the venues selected, we can return them, and that'll be the end of this function. So we can just return venues. We run our code just one last time. We can see that each of these array elements is now straight to the venue and doesn't have any of that useless information from before. With getVenues done, we'll move on to getForecast. This will be almost exactly the same process, so we'll move through it a bit faster. First, we'll use the async keyword to turn getForecast into an asynchronous function. So we just need to add the async keyword right before the parameters. Then we'll add our try-catch blocks and the error log. Try, and beneath that, catch with the parameter error. And catch is going to console log the error.message. Before the try block, we'll construct the URL to fetch. We'll start with the base APIXU forecast URL. This ends with an unfinished API key query, so we'll add on the API key as well. That'll be a new constant, URL to fetch, equal, and we're going to use backticks here instead of quotations again. We'll start with the forecast URL, and we'll append the API key. Next is the Q parameter, short for query. This is where we'll include the location typed into the search bar. So ampersand to put on another query, Q equals, and the parameter for that is going to be our input.val, just like we did in the last function. Lastly, we want to define the number of days that we use the forecast for and the time of day we want to check each day. We're going to do 4 days of forecast, and we're going to check 11 o'clock each day. So we're going to add on the days equals 4, and hour equals 11. Now inside the try block, we'll format our GET request, just like we did in getVenues. A new constant response equals await fetch URL to fetch. We can check for a successful response using response.ok. We'll save the JSON data if it is, and throw an error if it's not. If response.ok, then we're going to save our JSON response as await response.json. But if the response isn't okay, then we're going to throw a new error with the string request failed or something similar. Now we need to know what part of the JSON data we want to return. We can log JSON response to the console to take a look at it. So that'll be console.log JSON response. The part of this JSON we want is the forecast day object under forecast. So we'll need to save JSON response.forecast.forecastDay. Save that as a new constant, days, and that's going to be equal to, again, JSON response.forecast.forecastDay. This function is getForecast, and days represents the forecast, so we can return that and call this function done. We're just going to return days. The requests part of this project is done, so we're going to move on to the rendering part. Basically, this is the difference between looking at the data in the console and displaying it on a website. The renderVenues function iterates over each venue that we returned from getVenues. For each venue, we'll make some HTML that represents the relevant information, like the venue's name and icon. At the bottom of this function, there's already code for appending each HTML element to the page. Inside the for each loop, we'll save an individual venue by selecting one based on the current index. So a new constant venue is going to be equal to venues, and the index for that is going to be index. So here, venues is a parameter that we pass in, and that's going to be the list of venues that we return from our getVenues function. Then we're going to get the index of that array venues because we're iterating over them using for each. So this is going to run once per venue. Next, we'll save that venue's icon. If you were to look at the JSON object again, it would be under categories 0 icon. So we're going to save constant venue icon and set that equal to venue dot categories index 0 dot icon. The icon that will be displayed is stored at a Foursquare URL, and the data we just saved is only part of that URL. We can specify a size and whether or not the icon will have a background. We'll add BG for the background and 64 for the size. It's important to remember that this isn't anything universal. These rules are specific to Foursquare, so you'd normally have to go through the documentation to find out how to do this. We're going to set up our new constant, venue image source, and we'll set that equal to a string with backticks. We're going to add in the venue icon dot prefix, and then bg64. Again, that's adding a background and setting the size to 64. And then we're going to append venue icon dot suffix. And these are just strings that are part of this venue icon object that we got at venue categories 0 icon. Now that we have all the info we need, we can construct the HTML that represents this venue. In this video, I'm going to use a helper function for this because writing HTML isn't all that relevant to JavaScript requests. If you want to try it without the helper function, you can check out the linked template. We'll use the helper function, createVenueHTML, to get the HTML that represents this venue. We'll pass in the venue's name, location, and icon. So under venue content, which is already created for us, we'll use createVenueHTML. We're going to pass in our venue's name, our venue's location, and the venue image source that we created in the previous few steps. Render venues is done, so we just need to hook it up by passing in the venues from getVenues. In the execute search function, getVenues is already being called. We can add a render venues using then. We'll chain it to getVenues so that it starts as soon as getVenues finishes. So that's going to look like getVenues.then, and we're going to be taking venues out of getVenues because that's the return value, and we're going to be passing that into render venues. So we're passing venues from getVenues into render venues. Now we can finally see the venues rendered on the site. Enter a location in the search bar and scroll down to the bottom of the page to see the venues. The Foursquare API is completed now, from registration to request to rendering. We just need to finish off the APIXU half by working on render forecast. Just like render venues, render forecast has a for each loop that iterates over each day in the forecast. We'll get a specific day from the days array and save it as current day. So that'll be a new constant, current day equals days index. So we're getting our days from get forecast, and then we are selecting a specific day with days index. So this for each loop is going to have us go over each day, and we're going to render out all 4. We need to construct the HTML for this day. Again, you can try to build it yourself using the provided template, but for the purposes of this video, I'm going to use a helper function described in the next task. We can use createWeatherHTML to render the forecast data for each day. We'll pass in the current day variable and save the resulting HTML as weather content. So here, where we have letWeatherContent, we're going to trade out this empty string for createWeatherHTML, and we'll need to pass in that current day. Just like with render venues, we need to set render forecast to go off when getForecast is done requesting data from APIXU. We'll use then to chain the functions together. So we'll have getForecast, then we're going to pass the forecast on to render forecast, and use forecast as the parameter of that. So we get forecast out of getForecast, and then pass that into render forecast. Now, both APIs are completely hooked up. You can enter a location in the search bar and see both weather data from APIXU and venue data from Foursquare. We're done with the step-by-step tasks for this project, but it's great practice to challenge yourself by trying to expand upon the project. I'll give you some hints for each of the suggested expansions. To show 4 random venues, you'll need to change that for each loop in render venues. We already got 10 venues from Foursquare, but we're just taking the first 4. Try using a while loop instead of a for each loop, and be careful to add logic that avoids duplicate venues. To include additional information about the weather, you should take a look at the JSON object returned from APIXU. You can also look at the documentation on their website. There's plenty of data available from APIXU that we didn't use in this project. You'll probably have to edit the createWeatherHTML function to get extra information to show up. Putting additional info about each venue is just like doing it with the weather. Check the JSON for data that we didn't take advantage of, or go to Foursquare's documentation to see what's all available. Again, you're going to have to change create venue HTML. In my opinion, requests is one of the tougher subjects in JavaScript, so it's great that you were able to make it to the end of this project. We used GET requests to get data from two APIs, and then we used asynchronous requests, checked for successful responses, parsed JSON for specific data, and rendered that data in HTML. Requests are the way that two websites can interact, so learning how to format and use requests is essential for any modern web application. I'm Matt, for Codecademy. Happy coding!